I think there was some sequence error that he did, part of the demo glitch. If you do the sequence right, I mean, if you try 3-4 times, you can get through any file you want. And yes, that's the story. So what that really brings is security. Voip security is no more limited to Voip. Yeah, you need to protect the core Voip infrastructure, but more importantly, the security is now bleeding into data side, and the hackers can get access to your data on your laptops, on your smart devices. That's a key thing. And this is the time you guys have to realize that the Voip security is no more an island. You got to think beyond just an island. So I guess that's my presentation and demo. If any questions, please feel free to ask. By the IP. Yes. You don't have to. We have two ways to do it. You can send directly to the phone, deliver it to the phone, or deliver through the call server. So when you call your friend's number, right, the call server or the PBX is doing translation and converting that number to IP address. So you don't have to really know it, right? And usually once you know it, you know it. So what happens is, because of the peer-to-peer nature of voice over IP, once one call you make it, you know what is your friend's IP address, right? So after that, it is like, voila. So I can make 1,000 calls and learn 1,000 IP addresses, and then directly send, bypass the call server. That's the nature of voice over IP, which is different. Yeah. Yes. Yeah, SS7 payload is basically what's happening is the carriers, when they're interconnecting, they're also going over IP. But there are points where, because of the building reasons and because of the interworking reasons, the originating carrier in the classified speech would send a SIP message by attaching an IAM, right? IAM is a message that you would send to make a call, that has charging information, very blah information, LATA and all those stuff, which they care for settling, right? That information goes and then gets translated into a SS7, true SS7 message, like ISUP message, and then delivered to the STPs and security gateways, right? And if you could craft an SSN binary message such that it can cause a buffer overflow on an STP or a security gateway, you could do that. I mean, so imagine, yes, I guess if people are as old as me, but like there was in the 1990s, there was a huge outage of MCI network caused by an STP flip, right? When STP died and came back, it had a ripple effect. The entire nation had no long distance for some time. So things like that can happen in voice over IP by using this kind of. You done? Okay, now he got it. Sorry. I know it's something to do with as simple as sequence. Yep. Okay. Ooh. Okay. Now save. Okay. Now go to XLS. Can you do that? Yeah, okay. So, sure. You got to play with it a little bit, because I think, yeah. Okay, so go back to so he copied one of the file into his local drive. Now he can do. So he can browse the whole directory and look at the files and do whatever he wants. That's the key thing. Yeah. It happened. Yeah. We give vendors notice ahead so that they can work on it proactively. Very positive. I mean, they couldn't believe it happened, right? And they were very positive about it. The major challenge that the voice over IP vendors are facing today is catching up. The biggest challenge for them is catching up. Telephony has evolved over 100 years, and you have thousands of features that people are trying to replicate, right? And many of the features that you use, call diversion, the ton of features assume inherently that it is closed system, right? I can't spoof. I mean, it's a legitimate guy that is going to is making the call. I'm serving him. It's like concierge, right? It's not a guard. It's a concierge service. So that is the thing that we are used to. That's how it's different from data applications, because data application we started with a client-server model and suspicious model, whereas data is not like that. Voice is not like that. Now, you can start implementing some of these security software development practices, but there is still a chance that when you try to implement services on top of it, you would have same challenges, whether I trust this guy or not trust this guy. How can I know whether his trust level is? So those are the challenges that you face when you try to implement a software that works on voice over IP. Yeah, Bob. But that applies to any software development. Usually, it's not specific to IP telephony or voice over IP. You got to do just that piece of it, like code analysis, static code analysis or runtime code analysis using those tools. And everybody does that. The challenge is those tools tend to be very noisy. They don't know what really the problem is, because they're not context sensitive or state sensitive. So you may be able to weed out a lot of like script kiddie vulnerabilities by doing those analysis, but more sophisticated attacks are very easy to be created. Yes. Exactly. I think user interface, you brought a very good point. The user interface is a very important thing. If you keep challenging every time somebody calls somebody else, what is the user experience would be? We were never used to getting challenged, right? Imagine when we go to website, try to buy Ticketmaster tickets, we enter those squiggly characters that come in the image, right? Assuming translate that same thing into voice over IP. Yeah? Every time somebody calls, you go and challenge him. He'll be really annoyed. He's never used to it, right? Even though it's the best security practice, it's the worst user experience, right? And you got to find a balance between user experience and best security. In that sense, you have to really look into an overall security architecture, how to address this. Yep. Right. Yes, we do, because that's a reflection attack. You can start doing that when you take control of, you bounce off. When you do stuff, you send a request and it sends a bye response. So you send a bye to the phone. When there's no context, it ends up sending another message back to call server. So you can cause a reflection attack, right? So reflection attacks are very easy in voice over IP systems because there's a complex call state and protocol sequence that's anywhere you can insert and cause other people denial of service or cause denial of service on that system. Yes. So as we showed you just now, one is the voice over IP bleeding into data site. We show that, how you can take control of laptop and start doing whatever you want. The second thing is you can also cause denial of service on traditional telephone system, right? If you look at the 2 billion cell phone users, right, they're all vulnerable to Skype attacks today, right? I can write a script on Skype just to make the calls, right, for all the free calls. And what happens to all of those guys? Their phones, or I can send IMs to them. So there is nothing stopping me to not only just limit to Voip, but I can extend beyond. Sure. Yes, we did. There are vulnerabilities exist in H323 protocol as well at the application level. But what happened was, if you see the legacy of H323, it was always closed system. It's not an application. It's a very device replacement centric, where TDM is replaced by H323. There are hardly any few phones which are H323 capable. On top of it, the syntax and all those things are different. So today, if I am a hacker, H323 is not my golden pot. SIP is my golden pot. Skinny could be my golden pot. RTP is my golden pot, right? Because it's again just like security officers evaluate risk, the hacker evaluates what is the easiest way to get the maximum out of it. It requires quite a bit of algorithmic capabilities to detect these attacks, because they're happening at a call state level, which you need to really go deep dive. That's one of the things we bring to the table as a company. We have our group comes from deep expertise in building voice over IP products such as IPPVXs, soft switches. We leverage that technology understanding of how voice over IP can be attacked, and we brought in the security from major security vendors, and combined those